Okay guys, there's two major topics in here, and these problems are not hard, but they just get long, which is why I just want to give us some time today to not overwhelm you with two lessons. Okay, so yesterday I forgot to give you your practice problem, so hopefully I won't do that in today's lesson. Okay, here we go. So this one right here, guys, we were talking about this the other day, I think. I'm for real, Algebra 1 and Algebra 2 keep talking about the same thing. I don't know what you guys have done and what Algebra 1 has done, but ni modo, here we are. Here's the thing you guys need to know, that this right here, when there's a fraction underneath this radical sign, that actually means that you're taking the square root of 3 and you're taking the square root of 7, okay, on the bottom. The problem is you cannot have a square root in the denominator, okay, which I think we talked about the other day, right? Okay, so you cannot have a square root in the denominator, so you have to rationalize it. How do you rationalize it? You multiply the fraction by the square root that's in the denominator, okay? On the top and on the bottom. So how do you get rid of this? You multiply the top and the bottom, the numerator and denominator, by that square root found on the bottom, okay? So now you have 3 times 7 is square root 21, and square root 7 times square root 7 is 7. Can you simplify anything in 21? No, you can't really take anything out that's the square root, so your answer is square root 21 over 7. The only thing you have to make sure of is 1, can you simplify that? No. And 2, is there a square root still on the bottom? No, so you're good to go. Okay, this one right here, we're gonna write it as square root 2 over square root 5 plus square root 5 over square root 2, right? Okay, we have to rationalize both of them before we do anything else. We have to do times square root 5 over square root 5 and times square root 2 over square root 2, okay? Two different ones, so there's two different things on the bottom. So I'm going to write it down here now. It's going to be 2 times 5 is square root 10 over 5, right? Plus square root 10 over 2, okay? Now we have to find common denominators, you guys. The common denominator is obviously going to be 10. Okay, 5 into 10 is 2, so that's 2 square root 10. And 2 into 10 is 5, so that's 5 square root 10. You can bring these two together, and then you're going to get what? 7 square root 10 over 10. It looks like you should be able to simplify something there, but you cannot. Okay, process it. Watch it again if you need to process it a little bit more. It gets a little bit more weird, for example, 3 and 4, but not super hard. So here we go. Okay, so these are literally like the last one. However, they like to throw these numbers in front as well, which is totally fine, okay? So it's just gonna get a little crammed over here. What we have here is, I'm just gonna rewrite it up here to save us a little bit of room. That's square root 3 over square root 7. And this is square root 7 over square root 3, right? So I'm going to multiply this one by square root 7, and this one by square root 3 on top and bottom. So let's rewrite it. We have 3. Remember that this 3 applies to the numerator, okay? Even though it's big on the fraction, it's pegal with the fraction, and it applies to the numerator. So I'm going to have 3 square root 21, that's 3 times 7, over 7, okay? Minus 5 square root 21 over 3, okay? Then we can do our common denominator, which is going to be 21, right? 7th also for 21 is 3, so 3 times 3 is 9, square root 21, minus 3 into 21, 21 divided by 3 is 7, so 7 times 5 is 35, square root 21 equals 9 minus 35 is going to be 26, right? Yep, negative 26, square root 21 over 21. And that should be your answer. Yes, it is. Okay? This one, same thing. Let me rewrite this. And then, guys, every time that I write these on my papers, because I remember this from Algebra 2, I would write it like this to save a step. Or maybe I remember doing the test from before, I don't know. Here we go. So multiply this by square root 7 times square root 7. Multiply by square root 2 over square root 2. Okay? So we have 2 for this one. 2 times 7 is square root 14 over 7 minus 5 square root 14 over 2. Common denominator, I hope you can see it, kind of, yes, is 14, okay? So 14 divided by 7 is 2, so 2 times 2 is 4 square root 14 minus 2 into 14 is 7. 7 times 5 is 35 square root of 14. So you have 4 minus 35 is going to be a negative 31 square root of 14 over 14. Okay? It doesn't always work out that that number underneath is the same number here, but they did it this time. I guess they like the patron. Okay? Go over to now lesson nothing. Look, skip all this stuff, go over to example 5. Okay guys, example 5 is going to show you some relationships about triangles that we need to know. Like this one right here. If we have two triangles, okay, we already know that what these lines mean. Okay, we've already figured out that if these two angles are the same and these two angles are the same, that means that these angles are the same. Okay, here's the thing. That means that the sides are similar and we can make ratios, right, to solve for the x and the y and everything like that. However, what you're going to look for in example 5 is that there's also something new to look at. Yes, we could set up ratios and find our answer, right? We could set up ratios, we could say 6 over 6 equals this over this, right? We could do that. And we could solve our equation. However, what you also need to see is that if all three angles are equal and there is one side that is equal, okay? This side is equal to this side. Okay, if all three angles are equal and one side is equal, that means that actually these triangles are equal. They're congruent. They're not just similar, they're congruent, okay? So, keep that in mind. Yes, you could do your ratios. If you don't remember that relationship, you could do your ratios. You're going to figure it out. Don't worry, okay? But it's good to know, and it's easy to know that if you have all three angles are equal and one side equal, then actually these triangles are equal and everything is equal. So you can just do this. 6x plus 2 equals 12x plus minus 4. Instead of doing ratios, instead of doing fractions, instead of doing crisscross and multiply, and solve for x this way because actually these triangles are equal. So x equals 1. If x equals 1, you can put that in here. 4 times 1 is 4. 4 plus 1 is 5. So 5 equals p. Okay, so p equals 5 and x equals 1. Just to let you know that you can do it that way. Okay, so go ahead, using that information. Don't worry about the whole paragraph over there in the in letter C, but just look at letter C. The only thing you need to see there is that the two triangles shown here are similar by AAA. AAA means that they're angle, angle, angle. That means all three angles are the same. But look, one of the sides is also the same. It says two corresponding sides have a length of 4. So that means the triangles are actually congruent. Okay, so I give that to you, which means that you can do the process that you did here. Okay, so go ahead, do that. I'll give you your answers when you come back. Okay, here we go. I just got them a little bit set up. Your answers are A is 8 square root 15 over 15. B, negative 17 square root 14 over 14. X is 1 and P is 3. Okay, so let's figure this out. I just wrote them out easier for this. I'm going to multiply this one by square root 5. Multiply this one by square root 3. So I'm going to get 3 times 5 is square root 15 over 5 plus square root 15 over 3. My common denominator is 15. 5 and 15 is 3, so it's 3 square root 15. This is not a negative, it's an equal. Plus 3 into 15 is 5, so it's 5 square root 15 equals. 5 plus 3 is 8 square root 15 over 15. Okay, there you go. This one right here, I already wrote it where the 2 is applied to the numerator, the 3 is applied to the numerator, so I'm going to multiply it by square root 7, multiply this by square root 2. Bring it over here, it's going to be 2 times square root 14 over 7 minus 3 square root 14 over 2. The common denominator is going to be 14. Can you still see it? Yes, you can. Okay. 7 into 14 is 2, so 2 times 2 is 4 square root 14, minus 2 into 14 is 7, 7 times 3 is 21 square root 14. So you're going to be 4 minus 1 is negative 18 square root 14 over 14. I honestly don't feel like that's the answer that I just gave you, so let me just check that right here. I could just be losing my mind. Haha, square root of 17, which makes sense because 21 minus 4 is not square root of 17, negative 17. Anyway, I am losing my mind, so it doesn't really matter. Here we go, look at letter C. It already told us that all the angles are equal, so this angle is equal to this angle is equal to this angle is equal to this angle. How do I know? I think I told you this in another lesson before, but if you see these parallel things, that means that the angles across from each other, diagonal from each other, are the ones that are equal to each other, okay? So for that, I was able to put my little squares and my little circles. So that means that this is equal to this. So 4x plus 1 equals 12x minus 7. So I'm going to put my 4 over here, put my 7 over here. That's going to be 8 equals 8x. So x equals 1. If x equals 1, I'm going to put that in here. 4 times 1 is 4, minus 1 is 3. So p equals 3. Because that's the one across from it in the square. Okay? See you in the next lesson, guys. Let me know if you have any questions.